So it will become clear actually today when I will do. So maybe it will anyway come in the lectures of today, so it will become clear. But the question is, I'll just write it on the board this side. So yesterday I have defined this quantity. Let's call it Rn, which is the so yesterday I have defined this sum Rn, right, which is equal to I equal to 1 to n xi, right? I was calling it wi, is the same. So this is xi is a random IID random variables with mean 0 and variance 1. So it means that xi is equal to 0 and xi xj is equal to delta I, right? So now you are interested in the probability distribution of this variable Rn. So yesterday we showed that P of Rn, right? So it has this form. So exponential of n times some function, right? So this is some scaling function phi, which is basically a function of Rn over n, right? And this function is called, so if you take the negative of this function, sometimes it's called a rate function, or in physics literature usually it is called a large deviation function, right? And so this large deviation function is not universal, right? Unlike the central limit theorem, which gives a Gaussian form, it's not universal. So if you take different distribution, you get different function. Like yesterday I gave you one example. Did you calculate that function? Right? Yesterday there was one example. How many of you calculate the function? One? It's only you. Okay. So this function is non-universal. Yesterday was the case where xi takes value -1 and +1, right? But you can take any other distribution of xi, and what you will find it, you will get a different phi function. So only universality is that you know that this probability distribution, when Rn is of order square root of n, it should have a Gaussian form, right? So this Gaussian form is valid when Rn is of order square root of n, right? But this scaling is Rn by n, so this will scale it with n, right? So if Rn is of the square root of n, you scale it with n. So in the limit n goes to 0, how will it go? So it should go to 0, right? So that's why this function phi, in the limit the argument goes to 0, it should have a quadratic form, right? So it says that phi of x, limit x goes to 0, it should have this form -12 x square, because you know that in the limit, in that limit it is a Gaussian form, right? I have removed this prefactor, right? So it is a Gaussian form, and to get a Gaussian form you have to have this form. So as x goes to 0. So this is only the universality of this function, right? Whatever function you get in this limit, it should go to 0. So here x basically is the maximum is 0, that's why it's x going to 0, otherwise when the x goes to the near the x max. Yeah, so it has to be 0 because it is a symmetric function, because mean x is 0, right? So it is symmetric about 0, right? So for the sum also should be symmetric about 0. But if it has some mean, so then maximum will be somewhere else, right? Maximum will be around mu times n, right? So this I will, it will come today in some context. Yeah. Yeah. Around the center, this is between 0 and root n, let's say mod Rn. is less than equal to order n. At the tails, it will be of the order of n, so then this form is not valid. So this is, so this portion is, so this is for this one. No, so this one I know from the central limit theorem that it has to be a Gaussian form, right? And the central limit theorem is valid when this mod Rn is of order square root of n, right? Between 0 and of order square root of n. And I know that this is a quadratic form, so it should have this form, right? Yeah. Zero. In the limit n goes to infinity. So these are all Larsian results, right? So this is square root of root n divided by n, so it is of order of 1 by square root of n. So in the limit n goes to infinity, it's of order 0, right? 1 by square root of n, right? Yeah. So this is what it means, and you know this sign what it means, right? So this sign means basically if I take logarithm on both sides, so this is basically phi x, so this is for this one. So this function phi x is defined as, so if I take logarithm on both sides and divide it by 1 over n, right, 1 over n, then take log of p. Now Rn I have put x time x, e of Rn is equal to x times n, limit. So this is what this sign means, right? So it basically means that whatever the remaining term, those are subdominant term, and if I take these limits, and those term will be 0, right? Because this is 1 over n, and those terms will be, let's say here there might be a 1 over square root of n, so that is like a log of square root of n, right, divided by n, so those terms will go to 0, right? So this is what this sign means. So I think it will become clear today. So what I am going to do, something called a random walk. So how many of you have heard this term random walk? Okay, very good. So all of you have heard. So random walk, so I will do it in one dimension. So what is a random walk? So imagine you have a lattice, right? So the space, you just discretize the space, and right, so this is your space, some lattice space. Now you have a particle, let's say it is at origin, let's call this is origin, and you toss a coin. If it is head, this walker goes to the right, and if it is tail, the walker goes to the left, right? So if it is a unbiased coin, then going to the right will be, what is the probability of going to the right? Probability will be half, and going to the left will be again half. But if the coin is not unbiased, it is, let's say, biased. So these two probabilities can be different. So let's put this is P and this is, right? So with the condition that P plus Q equal to 1, right? So it is on the one dimensional line. So you toss a coin. If it is head, you go to the right. Toss a coin, again head, you go to the right. Tail, you go to the left, right? And you keep doing that. So you do it for n time steps. So all these time steps are also discrete, right? So it's like a, each instant is like a one time step. Each time you toss a coin is like a one. So now after n time step, the question is where will the walker be? Right, that is the question. So this will be a random variable, right? You do one realization, you will get one answer. If you do another realization, you will get another answer, right? The question is now, what is the probability distribution of that object, or average of this object, or variance of this quantity? So I think this yesterday there was some confusion about these averages, right? This whether we are doing time average or we are doing ensemble average. There is some confusion. So actually it's very easy to see what average we are doing. So imagine that this is your time steps, right? So these time steps are discrete, and this is the position of the walker. Putting on that, let's call it x, right? So these time steps are discrete, and x also discrete. It just goes by 1 or minus 1. So what is the equation for this one? So if xn is the position at the nth step, so it can only come from nearest neighbor sides, right? If it is somewhere here in the previous step, either it has to be here or it has to be here, right? So this is equal to x of n minus 1, so that is the position at nth step, plus some random variable, right? And this random variable takes values plus 1 or minus 1. So this takes values plus 1 with probability p and minus 1 with probability q, right? Or the other way. Okay. Yeah. So now, so if you plot this trajectory, how will it look? So you are here, you start, all the time you start from 0, because origin you just said whatever you start from. So first, so you will have trajectories, right? So these are all discrete trajectories, but okay, I cannot be so precise. So when I draw it, it will look like something, but this trajectory will look something like this, right? So this is one realization, it will look something like that. So these kings are supposed to be on this line, right? So then if you do another example, right, another experiment, again starting from origin, you will probably get something like that, right? So you do one more thing, so you will get something like that, right? So this, each trajectory will look different, right? These are each trajectory of a process. You start from 0 to capital N, right? So when you reach capital N, you stop, again you go to origin, again you start doing this experiment, right? So you will have something like that. So you do many times, right? Many times you do n steps. So now if you start with some time slice, let's call it this is capital N, right? So you will have lots of points, right? So this is from one realization, 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 right? You will have lots of points. So these points will also be random variable, right? So what are these points? These points are basically xn, right? This is the position of the walker at the nth step, right? So all the averages are with respect to these points, right? So these are ensemble average. You are fixing time, you are at one time, and you are averaging over different realizations, right? So this is my time, right? So it is this yesterday's class, so it is the same. So this time was continuous yesterday, but you just take it at one time slice and just measure all the position for different realization. So this is called different ensembles, right? So this is basically average over those different realizations. And now you can ask, what is the mean of these points? What is the average variance of these points, right? What is the probability distribution of this point, right? So this is the question we want to ask. So what is the probability distribution of xn? So this is the position of the walker at the nth step. So I'm going to, so I think Abhishek is also going to come back to this problem from a different angle. So this is actually, I mean, you should understand this random walk very well because it appears in many fields, actually not only in statistical physics, but many different fields. So what I am going to do, so first I am going to give a combinatorial derivation of this probability distribution, right? You might have already seen it already, but let's anyway do it. So you are tossing n steps, n times you are tossing, right? So number of steps is n. And at the end of nth step, you will be somewhere. So let's call this position x, right? So you are given n. So now out of these n steps, right? Sometimes you will go to the left and sometimes you go to the right, right? So let's call this number of steps L, which is to left and R this is to right. Right? So given this, I can write down some constraint equation. The number of left steps plus number of right steps is equal to the total number of steps, right? So this is equal to R plus L. Now that I start from here, so number of steps I to the right minus the number of steps I take it to the left. That should be my final position, right? Because all the time I am doing is, if I take all the time to the right, so I will end up at this n. If I take all the steps to the left, I will end up at minus n, right? So, and wherever the position in between is basically number of taking to the right step minus the total number of steps taking to the left, right? So therefore, this has to be equal to R minus L, right? This is what, right? So now how many ways I can take, let's say, R right steps out of n steps, right? And choose R, right? So number of ways of choosing R right steps out of n total steps is equal to n choose R, right? So this means basically n factorial divided by R factorial, n minus R factorial, which is same as L, right? Now, so what is the weight of each path? So what is the probability of each path? So each path I am taking some right step and taking some left step. The weight of taking a right step is equal to P, right? Probability of taking a right step is P, and probability of taking a left step is P, and each steps are independent, right? So if it is a independent, then the total probability is equal to the product of this individual probability, right? So it's like I am doing this and doing this and doing this and doing this and doing this, right? So these are just products, independent. So therefore, the total probability of each path, total let's say probability of each path is equal to P to the power R Q to the power L, right? So therefore, what is the probability of this process? I end up at, what is the probability that I take R right steps? So probability of taking R right steps is equal to this probability for each path, and I have to take for each path this probability. So this probability adds up, right? I do either this or this or this, right? So these are mutually exclusive events now. Either I do this one or this one or this one. So this will add up, but each of them basically how many paths are there? This one, and for each path is the same factor. So therefore this is n factorial R factorial L factorial P to the power R P to the power L. But now I want the answer in terms of x, right? Not in terms of R. But it's very easy to change this answer to the answer in terms of x because I have this relation, right? So I just need to write R in terms of n and x, right? So therefore, I guess you cannot see from there, right? So from there to down you cannot see all, right? Now, so what I'll do, I'll just remove this figure from here. So now, or maybe I can just write it here itself. So then if I just change it to P of, can you see here? It's visible, right? Okay. P of x n is equal to x, the probability that the position at the nth step is equal to x is equal to, so I just need to change this r and L to in terms of x, and what is r? So r is equal to, so if I add these two and divided by 2, that is what r, right? If I just add this to n plus x equal to 2r, right? So this is n plus x by 2. Similarly, L is equal to, if I just subtract this one from this one, right? So this L is equal to n minus x by 2, right? So this is what I have to just put it here. So I put n factorial, n plus x by 2 factorial, n minus x by 2 factorial, p to the power n plus x by 2, q to the power n minus x by 2. Right? So this is the answer. So this is the probability distribution. So x takes value from, what are the possible values of x? Huh? So minus n to n, right? So one is the extreme is the one I take all the steps to the left, or I take all the steps to the right, right? So this is the answer. Okay. So the other thing you note then, see it comes like n plus x by 2 and n minus x by 2, and sometimes so can it be fractional something? So let's say half, 5 by 2, 3 by 2. So why cannot be? Yeah, but if you add two integers, you can get 5, no? 3 plus 2 is 5. So n plus x will always be an even number, and why is it so? Okay. So n plus x is even, so that is because, see, suppose imagine I take a random walk of 2 steps, right? So what are the possible places I can end up? I start with 0, I go to 1, either I go to 1 or I come back to 0, right? Or I go to minus 1, either I go to minus 2 or come back to 0. So similarly, if you take n equal to 4, you will go here, here, come back here, or here. So if your n is even, the possible places you could end up after n step is all the even lattice sites. So if your n is odd, then only possible places you can end up is the odd sites, right? So therefore n plus x, so n and x, they have the same parity, right? If n is even, x is even, and n is odd, x is odd. So therefore their sum and difference will be always a even number. So if you divide by 2, then it's like n. Okay. So this is the exact answer. So now we want to find out what happened when we take large n limit to this answer, right? So this is the exact answer. So to large n limit, so this I will leave it as a homework problem, but let's just see. So you know what is the, so factorial n for large n, how does it go? Other person, right? So this is a good exercise to derive, because this is, I think, all of you probably have used it in some time or other. So this is something you should derive it. Right? If you use some result very frequently, you should know how the result comes. What if this result is wrong, right? So you should just derive it and verify that this result is not wrong. Okay. So this one, now if you put it here, so what do you get? So this I am again interested in large n, but x is of order square root of n. So you will see why I am looking at x of order square root of n. Let's, for the time being, let's say that I am looking at for large n, and x is of order square root of n. So therefore this n plus x and n minus x both are large, right? n minus square root of n in the limit n goes to infinity is a large number, right? So if you do that, so you know how to expand this one. So I will not do, but let's just put out Rn, right? So this goes like, so there is a square root of 2 pi coming from this one, there is a square root of 2 pi coming from this one, and there is a square root of 2 pi coming from this one, right? So at the end, what you will have is a 1 by square root of 2 pi, right? There is a square root of n coming from here, there is a square root of n plus x coming from here, square root of n minus x coming from here. So I can just take this n outside, so then 1 square root of n cancels with 1 square root of n, and I am left with 1 square root of n, right? So I have something like n 1 minus x by n 1 plus, so this first one is plus minus x by n. This I have, and I have all the rest of the terms, right, coming from, so this just comes from this square root of 2 pi n term, right? So I have all these terms, so I am not going to derive, write down those. So what you will find is that, so this will be something like E n times phi of x by n, right, because I can write everything in terms of x by n, right? I just have to put it, yeah, so you should try it, and if you know, then we'll just do it in the tutorial. But it will have this form, and there will be a factor of 2 here, right? There will be a factor of 2, and so this factor of 2 you can actually immediately see, because there is a square root of 1 by square root of 2 and 1 by square root of 2, so that 2 basically becomes this factor of 2 here, right? And this phi of n, and what is this phi of n? So let's call it phi of now y. So this phi of y is equal to half 1 plus y log p plus half 1 minus y log 1 minus p, right, plus log 2 minus half 1 plus y log 1 plus y minus half 1 minus y log 1 minus y, right? You will get something like that. So it is very easy. You just put everything, use this expression, and just put everything in terms of x by n, and this is what you will get, right? Because everything n by n, you can just write it as right, n log n, and then x. So this is what you will get, right? So this is for, so far I have not used the approximation that x is of order square root of n. So this I have not used so far, right? So if I now use this approximation, so you did you get something like this? You have calculated this thing yesterday, no? Was it something like this? Yeah. So this is yeah. This is my y is r. Yeah. It will be not exactly like that, but it will be more or less like this. So it will be actually, I think, this term here, right? Because yeah. So you'll see why it should be like this. Okay. So now, if you we are interested in when x is of order square root of n. So then you can expand this for small y and do the calculation. You will keep it up to the quadratic term. So finally, what you will get is P of Rn goes like 2 times 1 by square root of 2 pi n. Let me just put the, because you have Right. So this is 8 pi EQN. So you should derive this answer actually. I mean, yeah. So U minus x minus p minus q and whole square by 8. So this is what you will get. So in fact this, so it is not taking y goes to 0 limit. So the limit you have to take, see for p equal to q equal to half, right, you see 1 minus p is q. So then you know that it is symmetric about 0. So in that case you have to take y going to 0 limit. But for p not equal to q, so there will be a maximum, right. So you have to expand this function around that maximum. So you have to first find out what is the maximum, take phi prime y equal to 0, so it will give you the position of the maximum, and you expand around the maximum. So you know that if you expand around the maximum, it will be quadratic. So it will be actually very, so you should, what you should find that the maximum is at position p minus q by n, right, and this variance is basically this one, 4 pqn. So if you expand it near the thing, this is what you get. Okay. So you get a Gaussian, and is it reasonable that you get a Gaussian answer? Right? Can you guess that you should get a Gaussian answer? Right? So let's look at this equation again now. Right? We didn't do anything with this equation, right? We have not even used this equation, right? So if I use this equation, so what is xn? So what is x1? So x1 is equal to, so let's call it x0 is equal to 0, right? I am just starting from the origin. So what is x1? So x1 is this one, right? So what is x2? x1 plus 2, but x1 is this one, right? So this is just, so what will be x3? x3 will be x2 plus xi3, and xi3 is x2 is equal to xi1 plus xi2, so it will be xi1 plus xi2 plus xi2, right? So therefore xn is equal to n goes from 1 to capital N, right? So this one and this one, they are exactly same, right? So therefore this position of the random walker at the nth step is a sum of IID random variables, right, with mean. So if you calculate the mean, you will get some mean, right? If you calculate the variance, you will get some variance, right? So in fact if you calculate the mean will be 0 because it goes to either 1 or minus 1, right? So mean will be what? Mean will be p minus q, right? So for p not equal to q, it is not 0, so mean is p minus q, and variance, so you can again calculate the variance, right? So now if you know the mean and the variance of this object, so then you can calculate the mean and variance of this object, right? And then it should be a, the distribution of xn should be a Gaussian. This is why I put Rn, this is xn, no? X. Right, this is right. So then P of xn will be a Gaussian Gaussian with the mean and variance, and mean you will find that it will be for xn, the mean will be p minus q by n, and the variance will be 4 pqn. Right. So if you put, then what you will get, P of xn equal to x, so what you will get, so everything except this e power minus, so the same thing except this factor 2, right? This is what, this is the result from central limit theorem, right? So you got almost correct, but this factor 2, and what is this problem? This factor of 2, I mean, did I do something wrong? Sorry? This is what you are supposed to calculate. This is a homework problem. Right? Because you know I have told you how to calculate variance yesterday's class. Right? So I have given you that this guy takes value 1 and minus 1 with probability P and Q. So now that's a homework problem, you calculate the variance. Right? You know the definition of variance. So everything is here. So this is supposed to be calculated by you. So I am just giving you the answer. Right? But you have to calculate this and tell me that you get this answer correctly. Right? Yeah. So this, yeah, so the origin of this 2 factor is this. Let's write somewhere here. So what does this result mean actually? This x is still an integer, right? So what does this mean result? So this is some exact result, right? This is some exact result, and suppose you just plot x as a function, p of x as a function of x, right? So let's say n is even, right? So you'll get something like, so this is odd side, this is even side, 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 odd, even, odd, even, odd, right? So all these odd sides, so let's take the case n is even, right? So this result is for, then only for even axis, right? For all odd axis it is 0. So I should have written this result this if n plus x is even, 0 otherwise, right? So this is the actual result. This if n plus x even, 0 otherwise, right? So this is the full result. So therefore all these odd sides, my probabilities will be 0. So this points will be here. And all the even sides, so for example 0, I will have a point here somewhere. For this one I will get a point somewhere here. For this one I will get a point somewhere here. So this envelope, so this is, let's put a point something like this, right? So something like that, right? So I will get some point something like that. So these are all the even side. Right? You should actually do a simulation and find out. So these are the even side. It will be something like that, and this is given exactly by this formula. But now if I plot this formula, so what I will see is that it matches more or less like this, right? But then if I go far away from the origin, so it will basically divert from the exact curve. And this range is of order square root of n, right? So this is the region where the central limit theorem is valid, right? But the reason I am getting this 2 times, because here it is alternatively you have 0 and 1s, 0 and some number, right? Right? So now to get the central limit theorem, what do I have to do? I have to do some kind of coarse graining, right? Or the trivial coarse graining I can do is just add the probabilities of 2 nearby sides. So for one I will have this guy, for the other one I will have 0 divided by 2, this factor will go away, right? So this is the origin of this factor 2. Okay. So now I am going to do more let's say sophisticated coarse graining. Yeah. So before that, see that this function, let's say for xn equal to n, it is not Gaussian at all, right? You can calculate this function for xn equal to n. What is the answer? Right? You don't have to even look at this result, right? So if xn equal to n, what is the answer? So p to the power n, right? So p to the power n is the exponential function, right? It's e to the power minus n log of 1 over p, right? Because log of 1 over p is a positive number, right? So it's an exponential distribution, right? So the tail is in fact exponential. No, it's not Gaussian at all for this problem, right? So therefore this tail behavior is not given by this whatever is central limit theorem. But if you just plot from here, you just put y equal to 1, right? This is what x equal to n. So if you put y equal to 1, what do you get? You should get the correct result, right? You can check that you will get the correct result. Because this goes to this 1 plus 1, 2 divided by 2, it's 1, so it gives you log p. This goes to 0, this is there, this goes to 1, this gives you log 2, this log 2 cancels with this log 2, and this x log x in the limit x goes to 0, so you just put that, you should get this e power minus n log p, right? This is what minus n log, you get e to the power n log p, which is same as e to the power minus n log p, right? So this large deviation result contains also the result of the large tails, right? So you actually you see that in this case, whatever the exact result for p equal to n, you actually get from the large deviation answer, right? Okay. So now what I am going to do, I am going to do a continuum limit of this random walk. Okay. So let's skip this answer somewhere, right? So this answer I will just remove it because this is the answer I got from there. So I'll just skip this answer. Right. So now, so far I have talked about this, just the lattice. I didn't tell anything about the lattice spacing, right? So my unit is in terms of this lattice spacing, right? One lattice spacing or two. This x is this x is an integer, right? But now what I am going to do, I am going to introduce a lattice spacing, right? I say that this lattice spacing is a, right? So now, so I have this line, right? And I have this lattice spacing. So now let me just look it from far, right? So this picture will look something like that, right? So this is my lattice spacing A, which is much smaller than 1. So now I am going to look in a region somewhere here, which is much larger than this lattice spacing, right? So this, let's call it delta x, which is much larger than A, right? But again, this is again much smaller than 1, whatever it means, or it's basically much smaller than your system size, right? So this is again much smaller than, yeah, say 1, right? Or n, in fact, n times A, right? That is your length actually. So it's much smaller than, let's say, n times A, right? So because now I am going to measure in terms of this A, so NA will be the displacement, right? Earlier the maximum displacement was A, N, now it will be NA. So now I am going to define a variable y, which is x times A. So now it is my real distance measured in the unit of this lattice spacing, right? So if I do that, so what will I get? So now I cannot say that it is in exactly some point, because I am measuring with respect to this delta x. So now I will again look from very far. So this picture will look something like, this is my delta x, right, and these a's are somewhere there, right. So now I cannot say, now my y is a continuous variable, so I cannot say that it will be at this or this, right. It can be intermediate places. So only thing I can say, I am measuring y with respect to this in the unit of delta x, or I can just call it maybe delta y, right. So now I cannot say that, so this is my y, either y this is, but y I am measuring with respect to delta y, but this particle can be in between, right. So now only thing I can say that at nth step the Walker is between y and y plus delta y. And this is what I can say. And I don't know, because I cannot go to a scale which is finer than delta y, right? So I cannot resolve beyond delta y. So only I can say that it will be between y and y plus delta y, right? So now what is the probability of that? So this, let's call it p of y times delta y. Now this p of y is a probability density, right? So this is the probability that it is between y and y plus delta y, and that should be equal to the sum of all the probabilities, right? Because this is with respect to this p of xn, right? So this probability is same as either the particle is here or there or here or here, right? So this is equal to p of x sum over this delta y. Yeah, I should probably use different symbol, but this p is a probability density function and this p is a probability, right? Yeah. What is y equal to x a? So x is some integer, right? So x is integer, but now this lattice spacing is y. So now I am writing lattice spacing is a. So now I am writing finding the actual position, not the which lattice site. So x is the lattice site index. Let's say it can be at the excess lattice site in n step. But now I am actually, I have a scale and I am looking at what is the position of the Walker, right? And the scale unit is y. Now it's like a scale. You scale, you have this millimeter, this thing. So each millimeter line, you can think of it is x, right? You can say that in the millimeter scale I have to go 10 sticks, but then you will say, okay, this is 10 millimeter, right? So this, once you multiply by this y, it will be like a 10 millimeter, right? So this is the unit of one lattice spacing, right? Yeah, so where am I? So this is this, and so what is that now? So this now is equal to, now this range is very small compared to the full range, right? So I'll assuming that this probability doesn't change much within this range, so it remains constant, right? So it remained constant, so I'll just put p of x. However, it remained constant only at the non-zero points, right? So how do you do an integral? If you have to do an integral or sums from summation a to a plus some epsilon, where epsilon is very small, let's say fx dx, right? It's like doing an integral. So you see that this epsilon is very small, this function doesn't change much, right? So therefore this is equal to value of the function at some point times epsilon, right? This is how you do an integral, right? So I am doing the same thing, so I am multiplying the value of the function times the epsilon, right? What is my epsilon now? Epsilon is the number of points in the interval. So how many points are there in the interval? If my interval length is delta y by a, but in half of the points this probability is 0, right? Because I told you that this at all alternate points this probability will be 0, right? It will be 0, non-zero, 0, non-zero, 0, non-zero, right? So therefore, only points where this probability is a non-zero, it will be just half of that, right? So then I have to multiply by a factor of 2. Right? Is it clear? Right? Because this whatever the exact function, that is non-zero, 0, non-zero, 0, non-zero, 0. That's how it goes, right? Depending on whether n is even or odd. So therefore, this factor of 2. So now I can do everything. So what is P of y? P of y is equal to this delta y cancels. This 2 factor cancels with this 2 factor. Right? This 2 factor cancels with this 2 factor. So what you have is basically P of x replacing x by. So this is replacing x by. So what is x? X is equal to y by a, right? So then this is 1 by square root of 2 pi 8 pi. This 2 cancels, so this is square root of 8 pi 8 pi e q n. Then there is a. If I take it inside this thing, it will be a square exponential of minus x is equal to y by a, right? X, I see this for P of x, I have this formula, right? Right? Is it okay? So this implies P of y is equal to 1 by 2a P of x by P of x equal to y by a, right? From there I get this one, and now P of y by a, I am just using this formula, right? So what do I get? So I will get x is y by a, but 1 by a if I just take it outside, so it will be y minus p minus q a n whole square by 8 p q n square. This is what I get. Right? So what I have done is I have made space continuous. Right? So this is in fact a true whatever the result you get from central limit theorem, right? Now there is no 2 factor, it's gone. And if you have a so now instead of, if you write a xi which takes values plus a and minus a with probability p n with probability q, and then do the central limit theorem, this is what you will get. Okay, so this is consistent with the central limit theorem. So now next what we want to do is take the time continuous, right? We also want to take what is time derivative. So this result I will now remove it, and so far we didn't have the clock. There's no unit in the clock, right? We said okay, it just goes okay, step 1, step 2. We didn't say how much time you wait between 2 ticks, right? So now let's just put a unit. We say that in every second the worker takes small n steps. N steps in unit time, right? It's now in some time units. It can be either second, microsecond, millisecond, something. But in whatever unit, in 1 unit of time, it takes n steps, right? So then, the number of steps in time t will be what? N times e, n times t, right? If per unit time it takes n steps, this will be the number of steps in t time, and this is equal to the number of steps you have used in this formula, right? N. So therefore, if you have to write down the result in the continuous time, I am going to write in terms of this t. So I will write, replace n by nt, right? So if you replace n by nt, what do you get? P of y t, this is equal to what do you get? 8 pi d q n a square t exponential of minus y minus t minus q a n t whole square by 8 pq n a square, right? I didn't do anything except just putting n equal to n times t, right? So now I want to make this n is like 1 by n is like my unit time step, right? Because it's like a time step between two positions. If I just, what is the waiting time from one position to the another position, right? So that position I want to take it to 0. So that means I want to take it to n goes to infinity. So I also want to take capital N goes to infinity, but keeping, so I am going to put some limit. So n goes to infinity, capital N goes to infinity, while keeping t equal to n by n fixed, right? So I can do that, and I also want to take a goes to 0, right? My lattice spacing goes to 0, so I am just coarse graining now. So now see what are the thing we have to assume, right? There is something here, n goes to infinity, so this t is fixed, so therefore the a has to go to 0, right? So such that n a square is something constant, fixed, right? So this fixed number, let's call it 2t. Right? And maybe I should put d by 2. By 2. Yeah. So this is, no, I should take, let's take d by 2, and so then there is no problem with this term. So what do I get in this limit? So I get 1 by square root of pq n a square, I will put d by 2, right? So this is something finite, right? Fixed number. But now I have to look at what happened to this guy, right? So my a goes to 0, n goes to infinity, right? This one. So a goes to 0, n goes to infinity, but only thing fixed is a n square, right? So then a n will be what? Right? So an will be what? So an will be a square n by a, right? So now a square n will go to constant, but then there is a. So if I take a goes to 0, there is a problem. So to resolve this problem, what do I have to do? I have to also take the limit p minus q goes to 0, right? So therefore, I will take the limit p minus q a n is, let's call it mu, right? So if p minus q goes to 0, p goes to q, so that means half, right? P plus q equal to 1. So therefore, what is the limit I have? P equal to q, p of q goes to half, keeping p minus q equal into a times n is something constant, right? So if I take this, so what do I get? I think it's fine, right? So this, I think I just make it, yeah. Let me just see which one is that correct. So this is a pi, q is half, q is half, so it gives me 1/4, right? N a square, let's put it 2d. So this is 2d and t, right? Exponential of minus y minus, this is mu t whole square by same except the pi factor, right? So here and here only difference is the pi factor. Therefore, what do I get? So this gives me 4, right? So this gives me 4 pi dt, 4 dt, p of yt, whatever this limit is equal to yeah, p minus q goes to 0. Yeah, because p minus, yeah, I am not putting p equal to q equal to half. P goes to half, right? So it means that p equal to half plus epsilon, q equal to half minus epsilon, right? Epsilon is very small. Let's say epsilon is 0.00001, right? It is still a drift, right? So but in here, so those terms will be irrelevant. It will be half plus epsilon, half minus epsilon. If you expand in series, right, Taylor series, those will come in the power. So this will be, this is the first term, then the next term will be epsilon times something. So in the limit epsilon goes to 0, that term goes to 0, right? So there is still a drift, right? Okay. So this is what yeah, this is the result. So now let's try to write down something called a master equation, okay, and see what is the corresponding equation for this result, right? So let's write down this equation. So what is the evaluation equation? Xn equal to xn minus 1 plus the n plus or minus 1 with probability p and q, right? So now you want to find out somewhere. So what is the probability that occur is some at position some y at time t, right? So p of y time t, what is the probability that the position is at a between y and y plus dy at time t, because this y now in terms of this delta y, right? Okay. Yeah, for the time being, let's just write in terms of the lattice spacing. Okay. So what is the probability that it is at y at time t. So let's look at what is the probability that y at time t plus delta t. So it has to come from, so probability that it is somewhere here, that means in the previous time step it was either here or here, right? So this probability only depends on the probabilities of the previous time steps, right? So this is equal to, if it is here, then it goes here with a probability p, right? It takes with a probability p times probability at y minus a at time t, or it was here q probability of y plus a at time t. So this kind of process, or like where the probability just depends on just the previous steps, right? So these are called Markov process. So Markov process are basically you can write down in terms of if you just go to the continuum. Yes, you can write down with a first order differential equation. This is like a first order equation, right? Xn just depend on xn minus 1. If I just take xn minus 1, it's like a delta xn. It's like dx something, right? So if the probability of time step, it just depends on the probabilities of previous time step. So this kind of process is called Markov process. So if it is a continuous time, it's a Markov process. If it is a discrete time, you just call it a Markov chain, right? So this property is called Markov process. So now what I am saying is that in the dt time, so that I will come, so now my dt is basically just time step between two, so dt is the time between when the worker goes from one lattice side to the another lattice side. So this dt is my 1 over n in that other one, right? So I saying the per unit time it takes n steps, right? So 1 over n is the time step between time between basically the worker going from one lattice side to the other, right? So in dt time step it just takes one step, right? So imagine that it just worker waves and just after dt it just goes to some other time step. Okay. So I'm not going to solve this equation. This thing I think Abhishek is probably going to you are going to do that, right? Something, yeah. So I think Abhishek will do something this one. So I'm not going to solve this equation. So I want to find out that, so this is a exact equation for this process, but I want to find out the equation in this limit, and what is the equation, corresponding equation I get, right? So if I take this limit, so what do I get? So imagine delta t is very small. Why you are not comfortable with y? Y is my, no, y is my in terms of this unit, right? Y was xa, x was an integer, right? I cannot write x minus a, right? 5 minus 1 millimeter doesn't make any sense, no? Right? So this y is my, this in terms of this scale, right? So now let's write this one. So what am I going to do? I expand. This first term is p of yt. Second term is delta t del p del t plus higher order terms, right? I'm just doing a Taylor series. So let's do it on the right hand side also. So right hand side p p of y t minus a times del p del y plus a square by 2 del square p del y 2 plus so on, right? So similarly I do for the other one. So q times p y t plus a del p del y plus a square by 2 del square p del y square, right? So you'll see why I stopped here, but let's stop here for the time being. Right? I can go on, keep going on, but let's stop there. Okay. So now, what is P plus Q? Is 1. So this is therefore equal to P of yt. Right? This is the first term. So second term gives 1 minus P times P minus Q times A del P del Y plus A square by 2. P plus Q is equal to 1, right? Del 2P del Y square plus higher order term, right? So now this term cancels with this term and I divided by delta T, right? So what is the equation I get? Equation I get is del P del T is equal to, so this term cancels with this term. There is a term here. So minus P minus Q A by delta T del P del Y plus A square by 2 A square by 2 delta T P y square plus over delta T times whatever the higher order terms I have left out, right? So now I am going to take delta T going to 0 limit, right? So in this delta T going to 0 limit, what do I get? Del P del T is equal to, so what is this? So n is like 1 over delta T, right? So this is minus mu del P del Y plus A square, n is 1 by delta T, A square by delta T divided by 2 is D, T times del 2P del Y square. So what will be the third term? So third term will be of order A cube, right? Fourth term will be of order A to the 4, right? So now if you take those terms and divide it by delta T, and if you take this with this scaling parameter scaling, so you can show that those terms will go to 0, right? So do it actually, homework, right? So then this is the equation, right? Is this equation famous? How many of you have seen this equation? Okay, yeah. So this is a diffusion equation in the presence of a constant field. And if you have a charged particle, probably with a gradient or something, charged colloidal particle in a constant electric field. So this is the equation it will follow, right? So far I didn't tell what is D. D is basically given in terms of this microscopic variable. So what is D? D is basically A square by 2 delta T limit delta T, right? So this is how you define a diffusion constant, right? Okay. So this is this thing, and what is the solution of this equation? So this solution must be this one, right? Because it's the same. This solution I have arrived in a different way, this thing, but you should verify that this is indeed the solution, right? So one way to verify is just put it there and calculate it. The other way to verify it is to actually solve this differential equation, right? Okay, so yeah. Okay, maybe I'll just yeah. So do you have any question on this? So you will get the same equation. Yeah. Right. You can start with a equation where this walker goes something like that. Right. Now it goes something like that and then jumps, goes something like that, then jumps, goes something like that, jumps. Right. So these are the waiting time between two positions. So as long as this, so it will have some distribution. So P of tau, let's say. So as long as tau, P of tau, d tau 0 to infinity is some, let's say, tau 0 finite. So tau 0 just put a some scale, right? So it will have get the same distribution. Tau 0 you can put it up. This is some time scale basically. Right? But if it doesn't have a finite waiting time, then you will get something called continuous time random walk. So it will not be diffusive, it will be sub-diffusive, right? Yeah. Yeah. So let's look at this problem of Brownian particle. So imagine you have lots of Brownian particles. So don't think of gravity. Gravity is just one kind of force, right? So if you just think of gravity, it's just confusing. It can be any external field, right? You can have a charged Brownian particle with an electric field. That can be also a field which need not be along the direction of the gravity, right? So some Brownian particle, and in some external field F, that works on per particle. F, it's on per particle, right? And these particles are here. So let's imagine that this is a dilute mixture. So what are these Brownian particles? So imagine this is water, right, at room temperature, and you put lots of these colloidal particles. So typical size of this particle is 1 micron, right? So these are of 1 micron particles. Let's say you put in water, and then they are there, right? And there is an external force F, action per particle. So how should the particle behave? It's like a gas, right? And there is a pressure because of these particles. So what is this pressure called? So there is a pressure because of this water here, and there is a pressure because of these colloidal particles. So what is this pressure due to colloidal particles? I can hear something. Huh? Partial pressure. Okay. Have you heard something called osmotic pressure? Right. So what is the osmotic pressure? So how many of you have used a mosquito net in your life? Okay, lots of people, right? So imagine you are sleeping with a mosquito net, and okay, you are outside and you put lots of mosquitoes inside the net, right? And you are sleeping outside, right? But now this gas, whatever the gas you have, or mixture of oxygen, nitrogen, carbon dioxide, this gas can go in and out of this mosquito net, right? So therefore this gas is not going to put a pressure on the mosquito net. But these mosquitoes are going like randomly and they cannot go out. So once in a while they will come and hit the net, right? So that is a pressure by the mosquitoes, right? It's not the total pressure, it's just the pressure by the mosquito. So this is exactly the osmotic pressure. So if you put some membrane through which water can go but this particle cannot go, then particle will exert a pressure. And this pressure is osmotic pressure, right? So now what will be the osmotic pressure if it is the ideal gas? It should not be different from the ideal gas pressure, right? Because it is a dilute gas. So what will be the pressure? PV equal to N kVt, right? This kV is R by N, R by Na, right? Avogadro's number, right? So then if I just divide it by V, so what I have is kVt times rho of x, right? This is the osmotic pressure. Right? So now if you have a pressure, so the pressure exerts a force, right? So imagine that you have some small volume of these particles here. Imagine some imaginary wall. So this pressure will exert a force on that one, right? So what will be the force due to pressure? So you have to take the pressure here, take the difference of the pressure here, right? I think yesterday this Zain did in the class, right? How do you calculate this pressure, right? So it's the same, right? The force due to pressure is equal to, so force per unit volume due to pressure is equal to minus del P del X, right? This is something he did, no? You can take the pressure here, Px plus delta X, Px minus Px plus delta X, and then divided by the force here is pressure times the area. Pressure here is force here is pressure times the area, and then you take the difference divided by the area. What you will get is this one, right? So this is the force due to pressure, and then there is a external field, right? This external field acts on per particle. So then what is the force due to external force per unit volume, right? So force due to external force per unit volume. So this is equal to F is the force on per particle times the number of particle per unit volume, that is the density, right? But if you are here, you don't see things moving either here or there, right? So that means the total force has to be balanced, right? So total force is equal to 0. So if you balance the total force balance, what do you get? F times rho of x minus del P del X. P I will use this one, assuming the temperature is constant everywhere. So this gives me kBt del rho del X is equal to 0. Right? So this is the equation I get. Right? So now this particle are again in the external field, and in the external field this particle move, right? If you put a particle in the external field, they move, right? And after some time they reach a some velocity, constant velocity, and that velocity is called terminal velocity, right? Yesterday we discussed in the class. So this velocity will reach a this particle will reach a terminal velocity. So what will be that velocity? So force is F on per particle, then F has to be equal to the drag force, and what is the drag force? Is proportional to velocity. So F should be equal to gamma times V, and gamma is something proportionality constant. This is not the same gamma it was written down yesterday, but it is related to that gamma. Okay. So this is in fact 6 pi eta a if it is a spherical ball, right? So now therefore velocity is equal to force divided by gamma, right? So if that is the velocity, so what is the current due to this velocity? If lots of particles are going at a velocity v, what is the current? Density times the velocity. So current due to F is equal to rho of x times this. So F rho times V, this is equal to rho of x times F by gamma, right? Why should the pressure because of water change? So I said this is of the order of size 1 micrometer, and what is the size of water particle? For just curiosity, what is it? It's very small, right? So it's the size of this. So that water particle goes through the mosquito net, and this particles doesn't go through that mosquito, right? Yeah. So there's a distinction, clear distinction between the sizes, right? Okay. So now this is the current due to this, but so if you just release a gas here, let's say you just put some spray, after some time they move, right? So if things move, then there is a current, right? What is a current? You put a wall and ask how many particles are going through the wall per unit time. That's the current, right? Right? Per unit area, per unit. So therefore, since right, so then so what is the current due to this lots of particles are here? So what should be a current? So current should be, particle goes from high density to low density or low density to high density. It goes from high density to low density, right? So therefore the current, so that current is called the diffusion current, right? You put lots of particles here, they diffuse, right? And then if you put a wall there, you will see that particles are going through the wall, so that means there is a current, right? So what is this diffusion current? Diffusion current J is proportional to, so gradient of the density del rho del x. What is the sign? If del rho del x is positive, the current will be positive or negative? Del rho del x is positive means if you go this way, the density is increasing. So the current should be in the other direction, right? So there is a negative sign, and then there is a proportionality constant. Right, so that proportionality constant is called the diffusion constant. So in fact, this is how actually diffusion constant is defined, I guess, right? So, I mean, this is the definition. You can take this is the definition of the diffusion constant, right? So this is the definition of diffusion constant, and this is the current. So again, if you have this thing, you don't see anything going in one direction or just thing. So that means the total current should be equal to 0. Right? So what is the total current? So what is that? So F del rho del x equal to 0. Right? But are this one and this one, are there two different equations? So the same quantity rho of x, this is the equation for rho, right? So it's the same equation, right? These are not different equations. So if this equation and that equation they are same, so then what should you get? Right? If you just multiply by gamma, you get F rho minus d gamma del rho del x equal to 0, F rho minus kVt del rho del x equal to 0. So what is the answer? So what you should get is gamma times d is called right. So this is the equation we have this Sushant has used in the class yesterday. So this is called Einstein relation or Sutherland-Einstein relation. Yeah. So again I'll stop here because it's already this thing. But I'll just give you a homework problem again. So this is a very simple equation, right? So in fact, yeah. So this is a very simple equation, and so this in fact it should be just not the partial derivative, it's just the normal derivative now, right? Because I'm now assuming that this is independent of time, so only variable is x, right? So these are just so instead of partial derivative, these are just normal derivative, and you should be able to solve this equation. Right? The homework problem is solve this equation. Assume that f is constant, and solve this equation to get rho of x.